Hello and welcome to the second part of our first lesson in Unit 0. This is exponent laws. Now we're going to start to work through some of the examples, having already gone through a review of the rules in the table you can see above in your note. So let's start working through the examples. So what I'd like to point out here as we head into our examples is that example C1 says simplify by writing as a power of 5. Now simplify means express as a single positive power. So for us, for example, if we look at the first one, here we have 5 to the exponent 3 times 5 to the exponent 4. We're multiplying powers with the same base here, so we are going to keep the base, 5, and add the exponents, 3 and 4, giving us 5 to the exponent 7. Simplify means I don't care what 5 to the exponent 7 is. I don't have a calculator, I don't need to know what that actual number is. I can leave it as a power to a positive exponent. That's as far as we need to go. Let's work through some of these other ones. So here we have 5 to the exponent 4 divided by 5 to the exponent 2. So for us, what we need to do is recognize this is being divided. So if we have 5 to the exponent 4 divided by 5 to the exponent 2, the exponent law that we are going to apply is subtraction, which is going to be subtracting the denominator from the numerator. So we have the top exponent 4 is having 2, the exponent in the denominator, subtracted from it, which gives us 5 to the exponent 4 minus 2, which is 2. Again, we're just being asked to simplify here, so we don't actually need we don't need to figure out what that is. Let's have a look at C. C is 5 to the exponent 3 times 5 to the exponent negative 3. We're multiplying powers of the same base here. So the rule is we are going to keep the base and we are going to add the exponents. So we have 3 plus negative 3. Now, if you recall, if you have two signs sort of bumping up with no numbers in between, we are going to simplify that down to a single sign. And a positive and a negative combine to give us a negative. So if we have 5 to the exponent 3 minus 3, that's going to give us 5 to the exponent 0. Again, we don't have to evaluate this. We don't care what 5 to the exponent 0 is. We're just going to leave it here as a power to a positive exponent, or in this case, I guess, a 0 exponent. Last example, a few more steps. So what I'd like to point out with this example is we don't want to work across the division line until we've got our numerator and our denominator expressed as a single power. So what we've got here is essentially a set of imaginary brackets around the numerator and an imaginary set of brackets around the denominator. We need to figure out both the numerator and the denominator and simplify them to a single power before we start working across the division line. So if we have 5 to the exponent 6 times 5 to the exponent 7, we're multiplying powers with the same base, so we keep the base, and we are going to add the exponents. That's a 6 and a 7. And in our denominator, we have 5 to the exponent 3, whole thing to the exponent 3. So that's going to give us, that's a power of a power, that will be 5 to the exponent 3 times 3. And let's keep working this. So if we have 5 to the exponent 6 plus 7, that's going to give us 5 to the exponent 14. And in the denominator, 5 to the exponent 3 times 3 is 5 to the exponent 9. Last step here, we're dividing powers with the same base. We're going to keep the base, and we are going to subtract the exponents. And that's going to give us 5 to the exponent 5. And again, don't need to evaluate this. We're just going to leave it where it is. So this first set of examples hopefully reinforces some of the stuff we looked at in the table above. Now, if we move on to example number 2, we're going to see that we're being asked to simplify first and then evaluate. So there's two distinct steps in the solution, and as such, you would be getting two distinct sets of marks if you were writing this on a test or in an assignment. So let's start with the first one, 10 to the exponent negative 3. Well, we have a negative exponent. We deal with that by inverting the base, recalling that this is actually 10 over 1, as you would with any whole number. It can be written over 1. So we are going to invert the base, which gives us 1 over 10 to the exponent 3. That now is simplified, and you can see I've sort of identified that by putting that sort of that pink highlighter around this step. This is simplified now. As we move to the next step, which is evaluating, we need to figure out what 1 to the exponent 3 and 10 to the exponent 3 is. Well, 1 to the exponent 3 is easy. That's why we didn't even write it in there. That's going to give us 1. And 10 to the exponent 3 is 10 times 10 times 10, which is 1,000. and that is evaluated. So 2 parts to these ones. Let's have a look at B. So here we have 3 over 5 to the exponent negative 3. How do we deal with that? Well, it's a negative exponent. We deal with that by inverting the base. So instead of 3 over 5, now we have 5 over 3. Whole thing to the exponent now positive 3. And that's going to be applied to both numerator and denominator. At this point now, what we've done is we have simplified. This is simplified right here. This is a single power raised to an exponent, or a single base raised to an exponent, so it's a single power. We're going to go on though to evaluate. So if we have 5 to the exponent 3, remember I'm distributing this 3 to both the numerator and the denominator. 3 to the exponent 3, and now we're going to go on to evaluate this. So 5 to the exponent 3 is 5 times 5 times 5, which is 125, and the denominator is 3 times 3 times 3, which is 27. And now this has been evaluated. That's what we want. 2 distinct steps, 2 parts to the answer, 2 opportunities for marks. What this does is this basically assures the teacher that you know what you're doing and you didn't just type 3 to the exponent 5 to the exponent, or 3 over 5 to the exponent negative 3 into your calculator and working it out. Okay, and the last example here, we have negative 3 to the exponent 7 over negative 3 to the exponent 2 times negative 3 to the exponent 3. So again, remember, there are sort of invisible brackets here. We need to finish up the denominator as much as we can. So let's start by rewriting our numerator, ensuring that we include those brackets since that's our whole base. And we have negative 3 to the exponent 2 times negative 3 to the exponent 2. Multiplying powers at the same base, you're going to keep the base and you are going to add the exponents. So now we have a single power in both the numerator and denominator. We have negative 3 to the exponent 7 divided by negative 3 to the exponent 5. Dividing powers with the same base, you're going to keep the base and subtract the exponents. That's going to give us 2. 7 minus 5 is 2. So this now has been simplified to this step. Now we're going to go on to evaluate. And negative 3 to the exponent 2 is going to be negative 3 times negative 3, which is going to give us 9. And that has been evaluated now. So we're doing great. These make a lot of sense. We've got a couple more examples here at the bottom. Let's work through these. This one's pretty straightforward. We have 4 over 5 to the exponent 6 divided by 4 over 5 to the exponent 8. So what we have is division of powers. So we are going to keep the base, 4 over 5, and we are going to subtract the exponents. Now subtracting the exponents in this case, remember it's numerator minus denominator, so we actually have 4 over 5 to the exponent negative 2. It's not a problem. We know how to deal with negative exponents, right? We are going to deal with that negative exponent by inverting the base, which results in a positive version of that exponent. So here we have simplified, which gives us 5 over 4 to the exponent 2, and now we are going to go on to evaluate. So recall this 2 is being applied to both numerator and denominator. That's going to be 5 squared over 4 squared, and that is going to give us 5 times 5, which is 25, and 4 times 4, which is 16, and that now has been evaluated. So 2 distinct steps. Let's have a look. We have one more example. This one's a bit unique. This is like a total test question, by the way. This E here. This is the type of question we'll put on the test just to make sure that you don't get too wrapped up in what you're doing, and you'll see why in a moment. So what you've got here is you've got 3 to the exponent negative 3 plus 3 to the exponent negative 2. Now for us, we don't have an exponent law that deals with addition. We have multiplying powers of the same base, dividing powers of the same base, power of a power, but we don't have anything to deal with addition. So what do we do in this case? Well, we deal with each of these powers on their own, and then we combine them via addition later on. So 3 to the exponent negative 3 can also be written with that negative exponent as 1 over 3 to the exponent positive 3 plus, and then the same thing with our second power, 3 to the exponent negative 2. We invert our base, 1 over 3, and this is going to now become a positive exponent, which is a positive 2. So what we've done is we've dealt with the negative exponents. Now we need to go on and simplify this as best we can. So 1 over 3 to the exponent 3 is 1 to the exponent 3 over 3 to the exponent 3 plus 1 squared over 3 squared. Making sense so far, I hope? I'm just applying those exponents to both the numerator and the denominator. And now I need to evaluate a little bit in order to simplify this as much as I can. 1 cubed is 1. That's 1 times 1 times 1. And 3 cubed is 3 times 3 times 3, which is 27. 1 squared is 1, and 3 squared is 9. Now, for those who remember, when we're adding fractions, we need to have the same base setup. Now, in order to have the same base, the same denominator, I should say. So if I have 1 over 27 plus 1 over 9, I'm going to turn this fraction into 1 over, I'm going to shoot for 27 down here. I need to multiply the denominator by 3 to do that. But in order to keep this fraction equivalent, I need to do the same thing to the numerator. So my next line is going to look like 1 over 27 plus 3, that's 1 times 3, over 27, which is 9 times 3. And now, when you're adding fractions, you just combine the numerator, keep the denominator. So 1 plus 3 is going to be 4, and our denominator is going to be 27. And that is as simplified and evaluated as you can get. So we just have one more little example here at the bottom. I'm going to do that in part 3 of this video, so we'll see you in part 3.